you can stop the video and read this. I'm going to just get going on it. So I'm going to create a tree diagram to try and understand how this whole thing works. So I know I'm tossing 3 die, and I want to get 666. So one thing that can happen is that I get 666 on the first roll. If that happens, I am done. Okay. What else can happen? Well, another thing that can happen is that I'm going to get 2 6s, and I'm going to put N for not a 6. And that's another thing that can happen. 2 6s and not. And then I just keep going like this. What about this one? 6, but the other two not. Or another possibility is, I'm going to put it way down here, is I get no 6s. Nothing happens. Okay. So here I'm done. What's the chance of this happening? It's going to be, again, I have independence while sampling. So it's going to be 1/6 a third power, or the chance of a 6 and a 6 and a 6. Here, for example, it's going to be 1/6. I get 2 6s squared, but the third time I don't get a 6, so that's 5/6. And that's the chance of that happening. Great. If I'm here, I stop. But if I'm here, I got to keep going. So another thing that can happen is I get a 6, or I don't get a 6. Okay, but if that happens, because it's only my second roll, I can do it again. So I can go for a 6, and then the game stops, or I can keep going, and that's the end of the game, my third roll. So 666, the chance of this happening here is from here to here is 1/6, and here I have a 5/6, and again the chance of going from here to here is 5/6. So just to kind of complete this little portion, the chance of coming out of here, starting at this node and ending at the end, is going to be 1/6 to the second times 5/6, and then I have to go past this node right here, which is 5/6 again, and finally from here to here is going to be not 5/6, 1/6. So that gives me 5/6 squared times 1/6 cubed. And you'll notice that every ending that results in 3 6s will have a 1/6 cubed. This will also have a 1/6 cube. I'm not going to write it just because I don't have any room right now, but you can figure that out. So now I'll keep going because I'm not done with all the possibilities. What if I landed here? Well, if I land here, then I'm going to have to toss again. So one thing that can happen is I get 2 6s to appear. I'm only tossing 2 die now. I'm keeping the third one. And that's the end of the game. That's it. But another thing that can happen is I get a 6 and not a 6. If that is true, then now I keep this 6 again, and I'm only tossing this remaining die right here. So I get a 6, I end, or not, and that's my third, so that stops. Another possibility is I get no on my second attempt, so I got to toss now 2 die, and I can get a 6/6. Game ends. And then all these remaining ones are no good because I am not getting what I want. So this resulted right now in a winning. This also resulted in me getting my 3 6s. Okay, so I have these two, these not. Okay, this also resulted in me getting 6. This resulted, and so did this. Now, this bottom one is kind of lengthy. So here I am on my first toss. I get no. So then I toss all 3 die again. Give myself a lot of room here. So I get 6/6. Game's over. Okay, that's one possibility. I can also get the following. You can get 6/6 no, which in this case, this is my second rule. I can go 6 or not, and that's the end. That's my third rule. Here I get what I want, here I don't. Another possibility is that I get now 6 no, and if that's the case, I get to toss one more time 6/6, or um, 6 not, or not, but I'm never going to, well, maybe I should do just to be complete, not, but I don't care about these two because that's it. I don't win. I only win right here. And another possibility is that on my second toss, I get nothing, nothing, nothing again. If that's the case, boy, that means I'm going to roll all 3 die, and on my third roll, I either get 666, and that's the only winning strategy. I mean, I can be complete. I'll just do these, um, but none of these are going to result in a win. So this is the only one that results in a win. And what's the chance of that happening? Well, notice, in order for me to get to this point, I have to traverse the following branch, and that's 5, 6 to the third. I have to traverse this other branch here, which is also 5, 6 to the third. And finally, traverse this branch, which is 1, 6 to the third. So to end up here, I need to have failed this times this, 5, 6 to the third times 5, 6 to the third, that gives me 5, 6 to the sixth, and 1, 6 to the third. Here I'm also succeeding, but to get to this, again, spot, I have to have gone to the branch where everything did not come out right the first time. Then I go to this branch where it came out correct once and not correct 2 times. And I lost track of, oh, there we go, 5, 6 squared. And finally, on this branch, which is 1, 6 squared, and that is going to be 5, 6 to the fifth, 1, 6 to cubed, and so on. Then I just keep going in this manner until I get to the very end here. I'm not going to do all of them because it'll just take a while, and there's absolutely no point in doing this. But this would be 5, 6, and finally oops, that should be a 1. Doing this a little too fast. So again, that's this going down this set of branches right here. So that gives me 5, 6. Let's see how many times. I got 3, 4, 4. And that gives me 1, 6 cubed. That should be right. Okay, and then if I go a little more carefully, but in the end I have 1, 2, 3, 4, 5, 6, 7, 8. Should be 10 of them. Counted 10 before. Oh yeah, 9, and there's one more hiding. I'm sure there's 10 of them though. Okay, so that's the idea. Once I've calculated these, I got to add them all up to get my total probability. So taking all these paths, put them on Excel. And for example, this very first one is the 1, 6 to the third power. So you see the chance of rolling 3 die and getting 666 to appear is tens, hundreds, thousands, 10,000. So it's just a little more than 46 times out of 10,000 attempts. And there's there was 10 paths if you count them. If I add all those paths up, I get a new probability, which is greatly improved. I mean, it went from 46 out of 10,000 to now tens, hundreds, thousands, 10,000s to 442 scenarios where I get 3 6s, a little more than that, out of 10,000 attempts. So that's a vast improvement. So all that happens now is I count how many and add them all up. So I got 1, 2, just to verify, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There are my 10 paths. The rest of these don't work. But that's it. That's how you do it. If this process is important enough, this is kind of cumbersome, it's only 3 throws. Because, my goodness, how would you do anything else? Well, you start establishing a pattern. If this whole process is something that you're going to see often enough, then you would establish a way to come up with a formula that describes this scenario. And then we're going to meet later after the probability section a few scenarios that occur quite often, and they occur so often that they get names, they get formulas, and we explore all we need to explore about them. So for example, one of them is called the binomial distribution. It's a very special distribution, but it's very fundamental as well. So we spend the time to decipher how it works and come up with a formula at that point.